Good morning. So today I welcome everybody right now, not so many for the moment, to our webinar about line scan camera technology. And yeah, maybe based on our time shift from last week. Not everybody could make it today, so independently, I start with the webinar. We capture it online, and so everybody who doesn't have the option to attend the webinar can see it then later. Let's start. Today, we want to talk about high-speed inspection with line scan camera. Normally, line scan cameras are really old, but there are not so many companies and software products which can support line scan cameras, especially because the handling of line scan cameras is a little more difficult than normal area scan cameras. One reason we can see in our first image on the right side, we have an endless material and we see the line, and you get only an image when the product is moving. So our EyeVision software supports all these kind of capturing processes and enables our users to use line scan cameras as, or let's say 1D cameras, as we support 2D cameras in any kind of version, or 3D or thermal imaging cameras and hyperspectral cameras. All these image capturing technologies are supported by EyeVision. And of course, also for these different image capturing technologies, we have our specialized tool set, especially also for the image acquisition for line scan cameras. We have some specialized, we call it VICs, which enable our customers to use line scan cameras very easily, either as a very long image or as a never-ending image. Never-ending means image which we capture, and we have only a fraction always in our memory on which we operate, and we connect the resulting images or result values at the end of the process. So, of course, beside of these specialized tools which work, or tools which work on these different image types, we have additionally deep learning and robot vision, which can be combined with all these image technologies and all these standard algorithms operated on these different images. So it's really easy also to make robot vision with a line scan camera, especially if you have a production belt and the product's running on the belt. You can, of course, either use a 1D or a 2D camera, especially for robot vision, but for some kind of applications, line scan cameras are the better solution than the area scan cameras. So we have here a small schematic of the difference. On the left side, we see an area scan camera, which captures an image in full. And on the right side, we have the line scan camera, which always capture one line and connects these lines finally to one big image. Or if you have, let's say, endless production for woven or non-woven materials like plastic foil, metal foil in any kind, which are on rolls, then then a line scan camera is a better solution because you get a complete image of the roll. Of course, sometimes you would say, okay, you can connect area scan images to and generate therefore a real big image. That's one option, but the nice thing is if you use a line scan camera, you don't have to do this copying of images together and fit them together, because you capture always one line and connect the lines together and get therefore at the end a complete image without thinking how to connect them. Of course, because line scan cameras are much faster, the unsharpness of the images based on the movement is much better than I think we have another attendee which I have to accept. 1 second. It should be here. 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 Okay, so let's go ahead. So if you use an area scan camera, the image capture speed or the shutter speed or the maximal capture speed is not so fast as for line scan cameras, which finally results in problem of unsharpness in the moving direction. And therefore, at least based on this, line scan cameras are much better. They run, depending on the camera, up to 40, 50, 100,000 lines per second. And with the fitting speed, capture speed. Of course, the downside of this advantage is that if you run with a very high image capture speed, you need also a lot of light to simply illuminate for the fraction of time each single line. Another advantage of the line scan cameras are that the illumination. If you have an area scan camera, especially, you have to illuminate the complete area. And if it's a large object like a wooden panel or whatever, which is really large, it's difficult to have a homogeneous illumination over the complete object. And the advantage of the line scan cameras is you can exactly illuminate this very thin line of the line scan camera so that you have the best illumination in the area where the line scan camera captures the image. And therefore, finally, the image quality is much better than on an area scan camera. You have all these side effects from the lenses, because if you have an area scan camera, you have to illuminate, not only to illuminate the complete area, also you deal with the lens with the lens, so that you have in the complete field of view a non-distorted image. So for the line scan camera, you only have to optimize the lens for the line that it's not distorted, which is as well easier to be done as if you use an area scan camera. And the only disadvantage, however we want to name it, between the area scan camera and the line scan camera is, of course, you need, if your production belt is not with a homogeneous speed, you need an encoder to have a real perfect aligned image at the end. Finally, if you use an area scan camera and you want to you don't want to have a lot of overhead to do the image stitching. An encoder is also necessary. So there's not a real difference between the area scan and line scan camera for endless material. Of course, if you have an area scan camera, you see always an image because it's generated by the area scan camera. If you have a line scan camera, you see the image only if you have captured a bunch of lines, maybe 10, 20, 100, 400,000, however, which you can then display. If you only look to one line, you see only a very thin gray or color line, which doesn't give you a real view for as a human for what you want to operate. But finally, the algorithms work on multiple lines normally, so that if you have multiple lines, it looks also for the human then as a complete image, and you can operate on these image fractions as you operate on 2D cameras, but with the advantage lighting and lens is much easier to handle. So here we have this foil production. Maybe it's aluminum foil with small defects on it, or it could be also a plastic foil or woven material. The real advantage is, first of all, I mentioned it before, the line scan cameras does have a much higher rate of capture each line, so up to 400 kilohertz. And of course, you find also some faster lines, which allows you to run with very high speeds, with a very high resolution in the moving direction. And of course, the line scan camera are also available with a very high number of pixels in this line, in the line. So normally you get line scan cameras, of course, from the very low end, maybe 500 pixels, but you get it also with 16,000 pixels and more. And as we see it on this picture, you only have to illuminate the line where the area where the line captures the material. So this is much easier to illuminate this line perfectly than you have to capture an area with an area scan camera, especially if we assume this is now a reflective material. And if you have an area scan camera, of course you get, if you have a full illumination of an area, you get a lot of reflections. You can see here also some shadows and everything. You have these shadows in your area scan camera, and you have to deal when you evaluate the image with all these shadows and perfect illumination, or maybe also distortions of the lens. Finally, the resolution is very high, so that you get a very high resolution inline direction, and you can get the same resolution in the moving direction, so that you can get even the smallest defects with a very high resolution. And in many cases, resolution is enough to do the evaluation, to find the defects, and finally to do the perfect image evaluation. And always with the perfect image quality. So you only get the defects and you don't get the imperfections of illumination, which might cause or might look like a defect in the image quality, or it might look like a defect in the image, which you have to handle. So you can take only care with your algorithms on these defects, especially if they are small. These are the real big advantages of mesh or of line scan technology. Here we have a short view to a pre-scanned image. This is now a real image, and you see here all the small defects, and especially also the evaluation of the defects. which can be done endless. That means, as in the picture before, maybe you have on one side a production belt where you produce your paper or plastic or metal sheet material, and on the other side you roll it up and you get for the complete 2 kilometers or however material you produce direct the position where you have certain defects, and you can directly transfer these defects to the material roll and give it to the production belt for the if you process on this. And without additional software tasks to combine the area scan images with the defect. So this is a real big advantage, and especially if you have a lot of defects, you can classify them very easily and with the speed of the production belt. Of course, line scan cameras are also interesting if you have objects which are which you cannot capture with an area scan camera in once. For example, if you a classical example is a tire. You want to see how the tire looks like on the complete outbound area, and how to capture this image of the tires, whatever tire it is. So we have here some different tire patterns. And of course, to find defects or some other errors, not only for new tires, also for old tires. You could also place the camera on the side of the tire to get the to read the codes on the side. You simply rotate this tire and you get a complete unroll, and you can then operate on this unrolled tire to evaluate the complete tire and all the defects. Or if you have if you look for the dot codes on the outside of the tire, you get the unrolled dot code, and it's much easier to read it than you do it with an area scan. Especially, you get a real nice resolution with a very high dynamic range. So for all kind of this stuff where you have to watch the outside area, like pipes and other materials, for whatever inspection, you can use the line scan camera, which makes it much easier to get a complete unroll of the outer layer to the inspection and find exactly the defects where they are located. Here are, as I mentioned at the beginning, some examples from metal sheets to fabric and non-fabric, woven, non-woven material at the end. And even if you have woven material, the line scan camera is the much better operation, because you don't have to deal with the complete image while the production line is running. You concentrate on the position where you do the inspection and generate a clear view to all the defects. Here, an example in the paper industry, where you not only see, you can determine also the width of the paper, the outer boundaries of the paper, which causes in many cases, if you detect it very early, you can prevent that paper is damaged, and therefore you have a long time to restart the complete machine, because you can detect it very fast with the production line, with the resolution of the camera. So if you run the camera with the speed of the production line or faster, then you have a resolution from less than a micron, or anything between 1 micron and whatever you want to have more, so that you are always keep on track. First of all, the surface, if there are any defects or dirt or whatever in the production on the paper, but also the width and the damage of the paper so that you can stop it very early. And of course, for the paper, the illumination is not so difficult as so you could maybe, but not with the speed, use a 2D camera. But if we have a look here to this metal, once again, it's very difficult to get a good illumination of a shiny surface because you get a lot of reflections if you have a 2D camera. But if you have this 1D camera, you only look to exactly this small area where the line scan is, and you can do the illumination here perfectly, and then you get the defects very easy and very precise. Another application where, of course, you can use also 2D cameras, but maybe a line scan camera is a good option because it runs endless and it's independent on the on the size of the boxes or of what you're on your packaging. You get a very high resolution, which is really good if you want to do code reading, because code reading always depends on a really good resolution to do a safe code reading. And yeah, of course, these production belts or handling belts or however you name it, they never stop. So you can have the best resolution with the optimal light where the camera looks like, and you get at the end the complete box or the complete package so that you have a perfect image with the best resolution, independent if it's a smaller or a bigger box. It's much easier to handle it, and for all kind of these applications where parts are on a moving belt. Of course, the essential part, I just mentioned it at the very beginning of the for the line scan camera application is you need an accurate timing for the line capturing. So one option would be, which is not a real good option, that you have a belt which works very continuously and you know exactly the speed. Then you could run the line scan camera free with the hope that you never have any stop or something else. Or the real good solution for line scan cameras are always encoders. An encoder is a device which is connected to the production belt where the material is handled. And for each movement, it generates one pulse or multiple pulses per degree of movement. And for each degree, you generate 1, 2, 10, hundreds, depending on the encoder impulses, which results then in one or multiple line scans for the movement, so that you can generate each the resolution based on the encoder pulses per rotation degree. Finally, it results in the highest resolution you can do. The only limit is finally the line scan rate of the camera, and of course the light you can apply to the surface. This sounds somewhat easy, but if you really have very high line scan rates, you need very high powered light sources, which sometimes cause in damage of the material depending on the material. For example, if you have let's say only an 80,000 kilohertz 80 kilohertz camera with 80,000 lines per second, you need a light source which has some thermal power integrated in the light, even if you use LED light or maybe you use the laser light. And if your production belt stops, this power will apply to the object, and might damage your part. So this is, of course, one small downside of the line scan camera. If you go very fast with a very high line speed, you need very high powered light sources, which results at the end in very high temperature on the surface of your inspection material. But in most cases, this is not a real big difficulty, but you have to have it in your mind at the end. And of course, the optimization of the light, I just mentioned it before. If you have an area scan camera, it's always difficult to have bright field illumination or dark field illumination, because you have to illuminate always the complete area where the area scan camera looks or is inspects the field of view. And this is sometimes, of course, tricky to organize this for an area. If you have a line scan camera, we only have to organize this defect inspection, or this optimization of the light only for the area where you at the end apply where the line of the line scan camera looks to. So you have 1 millimeter width area where you have to optimize the light, and this is much easier than maybe if you have to illuminate a 10 by 10 centimeter or bigger field of view, where you have to optimize the bright field or dark field illumination. Especially it depends on the angle to generate the contrast in this field of view, and to make this contrast in this very small area, it's much easier than to do it in any bigger area. That's one of the big advantages between an area scan and a line scan camera, based on the illumination side. To give you a short overview, if you use our software, you have a full choice of camera manufacturers, so that you can get the line scan cameras from all currently known line scan manufacturers. There are not so many. So this slide before was an overview of the supported hardware manufacturers, but not all hardware manufacturer has also a line scan camera. But if you find, of course, a manufacturer, it's really likely that we support it. For the moment, I don't know a manufacturer which we don't support. Maybe a Chinese manufacturer which is new, which we don't support. But the other big advantage is line scan cameras come either with GigE interface nowadays, and if they are in the normal speed up to 16 or 20 kilohertz, and if it's faster, they come with the QuackExpress or Camera Link interface, which we both support, and therefore as long as we find a QuackExpress camera, or as long as it's a QuackExpress or Camera Link camera, we can support it to capture the line scan images to the main memory and operate on them. Of course, you can operate these systems as all of our software always on the supported operating systems. Our key operating systems for the moment are Windows and Linux. For x86 and ARM systems, so that you can solve your line scan applications also based on these hardware platforms. Yes, this was a short overview about line scan cameras and how to make it. Of course, as I mentioned, as a line scan camera is at the end a single line, which is easy to illuminate and easy also to adapt to a lens. Both makes it easier to optimize it to get a perfect image of the field of view with the line scan camera. The field of view is only the line. That's have to be in the in the background. And the advantages are mostly if you have endless material, or you have material which is handled on a production belt where you need a very high resolution. In both cases, the line scan cameras are the better solution for the application. In any case, if you have an application where you think maybe line scan camera might be suitable and you're not sure, feel free to connect to us and ask us what we can support or what we can suggest to you. We have a wide range of knowledge in line scan technology, not only in 1D line scan technology. Of course, the line scan technology is also available in 3D, mostly known as triangulation scanners or confocal scanners, which have the same advantage. Of course, you only look to one exact position. You have the highest resolution also in 3D, and also the complete setup for the triangulation lines technology in 3D is much easier, or is easier than you have an area scan based on no reflections and no other problems. So in any case, if you have an application where you think, okay, maybe line scan technology is the right thing and you're not sure, feel free to contact us and we will give you a suggestion. For today, I would round up and will say, okay, thank you that you attended our seminar. If you have some questions right now, I'm here. If not, feel free to send a mail to contact@evt-web.com, where you will get a complete response about how to do it, or if you need a direct discussion, we can also have a Zoom session where we discuss your application. Thank you very much for your attendance and hope to see you soon. Bye-bye.